Welcome back. All right, let's pull back the curtain on something really cool today. We're going to break down a complete production-grade system that uses machine learning to trade cryptocurrency, basically like a hedge fund. Let's get right into it. So let's just kick things off with a big question. What if you could build a robot that doesn't just, predict a number, but actually makes intelligent trading decisions all by itself, 24/7? That's the whole idea here. We're talking about taking that leap from simple prediction to full-on automated intelligence. And that right there is the first big idea we need to grab onto. We are not talking about some script you fire up in a Jupyter notebook. No way. This is a complete autonomous system, what you could really call a hedge fund robot, designed to operate in the real world. Now, this slide really hits the nail on the head. It shows the massive difference between a typical student project and a professional system. Your average project, it spits out a number, and that's kind of it. This system makes decisions. It doesn't just run once, it's designed to run nonstop in the cloud. And this is crucial. It actually factors in real-world stuff like transaction fees and risk. Plus, and this is a big one, it's always watching itself for what's called performance drift, which is just a fancy way of saying it checks to see if its predictions are getting worse over time as the market changes. The source material just sums it up perfectly right here. It's this beautiful, self-contained loop, right? It learns from data, it makes a prediction about what's coming next, and then it gives you a clear, simple signal. Buy, sell, or just sit tight. That's the whole game in a nutshell. Okay, so how does this robot actually think? The best way to picture it is like a factory, a data assembly line. Raw information goes in one end, and out comes a polished, ready-to-use trading signal. So let's take a walk down that line and see the different stations. And here it is, the entire workflow laid out beautifully. It all starts with getting the data. It's pulling live crypto prices right from an exchange like Binance. Then comes the real magic, feature engineering. We're turning those raw prices into smarter signals the model can actually learn from. Then we train the model, in this case, a beast called XGBoost. Next up is a super important step, backtesting, and we'll talk more about that in a sec. And finally, it's go time, making live predictions and, just as importantly, watching its own back for that performance drift. That very first step, getting the data, it all comes down to this classic saying. It's so true, isn't it? The entire intelligence of this thing is built on the data it eats. If you feed it garbage, well, you're gonna get garbage results. Simple as that. Okay, remember step 4, backtesting? I love this definition. It's literally a time machine for your trading strategy. This isn't just a nice to have, it is an absolutely critical safety check. It lets you test your robot on historical data to see how it would have done in the past. It helps you catch huge mistakes before there's any real money on the line. All right, so we've got our assembly line, our process. But what machinery is actually running it? What are the tools on the factory floor? Because building a robot like this isn't about one single piece of software. It's a whole orchestra of pro-level tech all playing in harmony. And this table gives us the perfect bird's eye view. For the brains of the operation, we've got Python and the super powerful XGBoost algorithm. For MLOps, which is all about keeping these models alive and healthy in the real world, you have tools like MLflow. The whole system gets packaged into neat little containers with Docker and then managed by Kubernetes, which acts like the ultimate factory floor manager, directing traffic and making sure everything runs smoothly. And the best part? It's all automated using GitHub Actions for CI/CD. This is the stuff that separates the hobby projects from the real deal, reliable systems. Having the right tools is one thing, but where does this factory actually live? Well, it's not on somebody's laptop, that's for sure. This system is designed to run non-stop, completely on its own, in a full production environment, up in the cloud on Amazon Web Services. Now, I know what you're probably thinking. Production-grade cloud infrastructure? That sounds expensive, right? Like crazy expensive? Well, this was one of the most surprising details for me. Check out the estimated monthly cost. So what does that price tag actually get you? I mean, this is the amazing part. You're not just renting a single server. You're getting a complete professional infrastructure. You get that Kubernetes cluster managing everything, the ability to automatically scale up if things get busy, a managed database so you don't have to deal with it, massive data storage, and all the tools to monitor the system's health 24/7. It's an incredibly powerful and self-sufficient setup for that price. So we've seen what it is, we've seen how it works, but let's take a step back. Why should you even care about a project like this? Well, because it's a blueprint for the kinds of skills that are insanely valuable in the job market right now. Look at it this way. Building, or even just deeply understanding a system like this, is a massive asset for your career. It's a killer portfolio project because it proves you can do more than just mess around in a notebook. It shows you can build a real end-to-end production system. It demonstrates those in-demand skills in MLOps and cloud engineering. And maybe most importantly, it signals that you get how to think like a quant. You understand risk, you understand how to apply data to solve real business problems. That's a huge deal. And that's really where we land. This whole project is a powerful template for turning data into automated action. And these principles, they don't just apply to trading crypto. You can apply this framework to so many different things. So the final question I'll leave you with is this. If you had this blueprint for automated intelligence, what problem would you solve with it?